Welcome, AP Calculus students. It's me, your friendly neighborhood AP Calculus teacher. I would like to encourage you to do hopefully what you normally do with videos, namely look at the problem, pause the video, and complete the problem. What I'm going to do is talk through my solution, look at scoring, and then look at how this problem fits into how we're reviewing for the AP exam. So I'm going to assume that you paused and tried said problem. Took you in the neighborhood of 15 to 20 minutes. I just realized that hopefully used a calculator here. That's a bit of a yikes. But anyway, let's talk about my work. So free response questions are always 9 points. Part A is 2 points. Part A, we're challenged with finding the cubic feet of rainwater that flows into the pipe during the 8-hour time interval, 0 to 8. So that's definite integral from 0 to 8 of the function r of t. I got 76.570, accurate to 3 decimal places. Units are cubic feet of water. As it turns out, if you look at the scoring guidelines, which we will soon, didn't actually need units here, but that's okay. It's never wrong to include correct units. So how did I know to do this? Well, I knew that from reading the context of the problem. It says water is flowing into a drain pipe at this rate. Water is flowing out of the drain pipe at this rate. Since we want to know the amount of water flowing in, the total amount, we want to integrate the change. Part B, is the amount of water increasing or decreasing? So, thought to myself, well, first thing I thought was wrong, and that's okay sometimes. Sometimes you're going to do that, let it happen. It's actually not the water flowing in, which is R of T, it's the amount of water in the pipe, and there's 3 things. So there's the 30 cubic feet of water in the pipe. There's the water flowing in minus the water flowing out. So that's where this equation comes from. So this thing right here has to be bigger than 0 for the water in the pipe to be increasing. This is smaller than 0, the water has to be decreasing. So I calculate R of 3 minus D of 3 using my calculator. So I literally type those 2 functions in that were pictured before, subtract them, I got negative 0.314, it's accurate to 3 decimal places. Then I answer the question. Since this value is negative, the water in the pipe is decreasing at t equals 3. Part C, when is the water in the pipe at a minimum? So it doesn't say absolute minimum, but it means absolute minimum. And when it says absolute minimum, what I need to do is I need to think about all of the possible values where this could happen. There are 3. They are 0 and 8, because those are the endpoints, and then any values between 0 and 8, where the first derivative equals 0. You could also think about it as just where the first derivative equals 0 and changes sign from negative to positive to be a minimum. But I didn't bother doing that. I just looked at solving this equation. R of t minus d of t equals 0. Again, that is done completely on the calculator. Quick note, if you have a calculator active question, don't think about doing hardly any algebra. Think about solving on the calculator. So when I solved on the calculator, I got these values. I stored this value. Then I took 0, 8, 3.272, put them into the function, got these values in cubic feet, and this one is the smallest, therefore the minimum. Part D again, the pipe can hold 50 cubic feet of water before overflowing. Write but do not solve an equation involving 1 or more integrals. Here's how I decided to answer that. I kind of answered this idea already. I said that there's 30 cubic feet in there. There's 0 to W water coming in, 0 to W water coming out, and that needs to equal 50. And we'll shift our attention here to the scoring guidelines. I know there's scoring on my paper, but here it is all at once, nice and concise. So point for the integrand, Make sure you have limits of integration. The function, you can do R of t or the formula for R of t. Just make sure it's the right formula, dt. This says considers R of 3 and D of 3. So you didn't have to do exactly this, but you had to do something equivalent to this. What does that mean? Hard to answer in general. But what I'm saying is you don't have to do exactly this to get the point for considering these. The second point is for answering with a reason. The reason is this is negative, which could be expressed by adding D of 3 to both sides. R of 3 is less than D of 3. Part C, 3 points. Again, consider, that means in some fashion you have looked at this. Maybe you didn't solve it correctly, maybe you did. And then in some fashion, determining which of these results in the minimum amount of water in the pipe. That gets you your 3 points. So this part right here is your justification. I know it has justification last, but this is your justification, doing something equivalent to saying, here are all of the possible values, or here are all the things that where this could happen. Here's the one that matters. And then finally, pretty much the exact same equation that I had. So again, it's water coming in, integrated, because we want the total amount of water coming in. It's water going out, again, integrated, because we want the total amount of water coming out. There's 30 cubic feet of water in the pipe at 0, and this needs to equal 50. Thanks for watching.